Welcome to our online breakout session about fuel flexibility, embracing flexibility for the energy transformation with paraffinic fuels and hydrogen. Today, Michael, Robert, and I will navigate you how decarbonization from Rolls-Royce Solutions perspective can look like today and beyond. Robert and I will navigate you through paraffinic fuels by focusing on HVO. Our technical experience and expertise, as well as a customer-centric solution approach to ease switch decisions. Michael will give you insights into the status and upcoming hydrogen solutions. My name is Anna Keller. I'm product owner for the project Sustainable Engines, heading the partnership with Nestle, biggest upstream player for HVO, and focusing on the decarbonization of our fleet. Did you know that 85% of the global playing companies are focusing on sustainability and partners who are doing decarbonization activities? Currently, this is key to close sustainable partnerships. This is our fuel roadmap, which discloses the most promising fuels for a greener tomorrow. In this session, we would like to bring the spotlight on the paraffinic fuel HVO, because it's a decarbonization solution already today, which can be integrated into existing infrastructure, especially suitable for backup power, and hydrogen as an all-purpose solution for continuous power in the future. First of all, I would like to step into HVO. It's within the EN 5940 norm, and now I would like to deep dive into the advantages of the HVO. First of all, it's a drop-in fuel. So it has a similar chemical compilation like fossil diesel. Any blendings or pure usage are possible. Therefore, users can just plug and play. The main advantage compared to a fossil fuel are the up to 90% CO2 savings. This is valid for Europe. Our product is a reference product, Nestle Renewable Diesel, from our strategic partner, which is made from 100% sustainable sourced renewable materials adherent to the Renewable Energy Directive. Additionally, HVO had a longer shelf life due to the absence of oxygen. The fourth advantage is that HVO is odorless, which means you have no aromatics and no naphtha, which mainly causes the black smoke or the typical diesel smell. Fifth advantage is the high cold resistance of Nestle Renewable Diesel. It is well suitable for cold areas. And the last advantage are potentially lower operating costs. This is due to the longer shelf life. You can potentially derive a business case and reach a break-even point. And you can already decarbonize today because it's already available in 28 countries. Now I would like to hand over to Robert.
Thank you, Anna. My name is Robert Welz and I'm Senior Manager for Power Gen Engine Support. In this role, it was with my team to coordinate the release of HVO, or more specific, fuels according EN 5940, which HVO is a part of. First, I would like to talk about the journey from the first rumors in 2015 in the market that there's a new fuel type coming up until 2023, when we released these fuels in our fuels and lubricant specification. The rumors got concrete when the first customer requests for fuels according EN 5940 were received in 2016. The very first was STORE, or Short Time Operating Reserve project in the United Kingdom. We then, after we received this request, started with engine tests in Friedrichshafen and analyzed the material compatibility in our chemistry laboratory, as we saw issues in the past with biofuels like FAME or RME. These analyses contained, for example, lubricity, pressure rise rate, and material compatibility. And our partner at that time was already Neste. After we performed the test with a positive outcome, we agreed with the customer that he can use this fuel, an HVO, for this project. Following this first project-specific release, In the time from 2016 to 2022, we were asked in 55 cases for a project-specific release for these fuels. With 24 of these projects, we agreed to the usage of this fuel after we discussed the potential risk with the customer. It was important for us to be open and transparent. But on all customer sides, no negative experiences were made. In parallel, we worked on a general release of fuels according EN 15940, so that we could add them to our fuels and lubricant specification. But to do so, it is important to gather experience. For this, we did several back-to-back tests to compare emissions, load acceptance, peak power, fuel consumption, etc., both in-house and together with customers. But in power gen, you face the problem that the engines normally have a low amount of runtime hours. To get information about how TBO is affected, we had in parallel long-term tests in other applications. For example, more than 9,000 hours of engine operation on a ferry. Additionally, our chemistry department had a master thesis written about material compatibility. So finally, with some additional test runs and the experience from the customer sides, we were able to release fuels according EN 5940 in 2023. The outcome of all these tests and feedback from customers is summarized in this slide. Our today's portfolio is released for fuels according EN 5940 as a drop-in fuel. We have a restriction on Series 2000 Go6 for the high-pressure fuel pump, but this is something we are already working on. As you can see, the engine behavior stays unchanged. You have nothing to consider. Just refuel your engine with, for example, HVO. The TBO, power output, warranty, etc. are unchanged, as you need no different hardware or software. You don't even have to change the fuel filters. Also, any blend or mixture with any other fuel listed in our fuels and lubricant specification is possible. But one thing changes, and it does to the better: the emissions. Here you can see that the predictions about emissions given from company Neste were confirmed by our engine during back-to-back tests. The biggest improvement you see in soot particles. With this slide, I would like to share some details about one of the tests we performed. Here we used a 20V4000 G94LF in standby application in a back-to-back test. And we also ensured to have the same ambient conditions. So the test was performed within 2 weeks on the same site on the same engine. On the left side, you can see the emission reduction in different load points between 10% and 100% load. And in my opinion, these numbers are speaking for themselves. The soot our particles are reduced by up to 82%. And please consider that the CO2 reduction named here is reduction in the burning of the fuel, which is an additional effect to the CO2 reduction stated by the fuel supplier given by the production process. On the right side, you see a comparison of something many customers asked us about. How is load acceptance, one of the key criteria, especially for data centers, is affected? And as you can see, load acceptance is not affected at all. Any difference we measured during our back-to-back test was within the tolerances of our test equipment. By the way, we also did a load acceptance test on a KPP genset with the same outcome. And now back to Anna.
Thank you very much, Robert. I would like to step in and give you an insight how we can anticipate customer pain points. Beside the fact that we release our recent portfolio, we noticed that most customer pain points revolve around availability, accessibility, and affordability. So what is the volume globally of HVO? Where can I get it from? And what are the costs? Rolls-Royce Solutions closed in 2022 a strategic partnership with Neste, as already mentioned, a global leading player and HVO producer, to set up a HVO competence center and consult customers to e-switch decisions. So focusing on the point availability. On a holistic basis, we are able to give insights into upstream volumes. For instance, until 2030, the annual growth rate is bigger than 20% annually of HVO, as well as into market players, their roles, and also about product qualities, which is the most important factor for real and transparent sustainability. Within the accessibility, we can offer to customers a deep dive into relevant markets regarding regulations and benefits. An additional value for the customer is our best practice sharing on qualitative characteristics of HVO, which can be considered into the tenderings of a customer to receive a full, reliable product in terms of sustainability. So the last pillar, affordability, is focusing on price transparency. We can give you insights with our HVO cost calculation tool or TCO calculator to set switching costs into perspective. Furthermore, we are able to give insights into pricing mechanism as well as leverages within emission trading systems. We are in strong connection with nested fuel distributors to elaborate business opportunities for our customers. Exemplary, the quote in the lower area of this slide is a data center customer. We were able to consult the customer within the last year and convince them to switch on HVO, in this case Neste My Renewable Diesel, within 3 months, although he thought about switching on an alternative fuel for 6 years. We consulted the customer with Neste and connected them to a suitable channel partner. This was our section about HVO and our product portfolio we released, and now I would like to hand over to Michael.
Anna, thank you. My name is Michael Wagner and I'm leading product management for our stationary business. In our product roadmap, hydrogen for the use in internal combustion engines play an important role. The physical properties of hydrogen are very different compared with natural gas and therefore require significant engine adaptations, as well the safety concept is impacted. Which are the most important physical properties? First, the energy contained in 1 cubic meter of hydrogen is less than 1/3 of the energy contained in 1 cubic meter of natural gas. So it means we have to bring a big volume of hydrogen into the combustion chamber. Second, the energy needed to ignite hydrogen is very low. And number 3, the flame speed when H2 burns is very, very fast. So to keep the combustion under control, we operate the H2 engine very lean, means with a high air-fuel ratio, which is called lambda. Essential components to be changed to be able to, number 1, keep the combustion under control, and number 2, as well, what's very important, to be able to convert already installed natural gas systems for the use of hydrogen are the following. First, we are using multi-point injection systems, means that we inject the compressed hydrogen into the compressed air before the inlet valves of each single cylinder, so-called multi-point injection. Therefore, the turbocharger design has to be changed as we compress only air in the turbocharger, which then is cooled in the air cooler. Number 3, the piston design is optimized. We are using a reduced compression ratio. And last, of course, the engine controls are optimized to handle the multi-port injection principle, and as well each single cylinder is pressure controlled. And with this concept, we can proudly say that all of our installed natural gas systems are hydrogen ready. Safety is very important. So with our in-house designed and produced container concept with 3 separated rooms and specifically safety measures, we are enabled to achieve the CE conformity. Our hydrogen gas train system is able to be flushed with nitrogen, so inert gas, when, for instance, maintenance work has to be done. We have a separate engine room which contains the heat recovery system, the oil management, and all the other auxiliaries, so to be separated from the engine section of the container system. Within the main engine room, we use, of course, hydrogen detectors. And to be on the very safe side, we have designed a slightly oversized engine room ventilation system as well. What's our status? So we had the first fire of the first hydrogen engine at our test engine in May 2022 already. Since that, we have achieved more than 700 operating hours running on pure hydrogen. Second, we made significant investments at both factories in Augsburg as well as in Friedrichshafen, so investing in the hydrogen infrastructure. And number three, in the next couple of months, we will ship the first 1 megawatt each CHP systems containerized, running on pure hydrogen for the port of Duisburg. Our hydrogen journey is set up in a way enabling our customer to transform from natural gas to CO2-free power generation over time. First step is or was that already now our natural gas, our latest generation of natural gas engines can be operated with up to 20 volume% of hydrogen contained in the natural gas. So that's the status quo. Our first generation of pure hydrogen engines are targeted to achieve a specific output in the range of 100 kW per cylinder. Meanwhile, we are very confident then that we can achieve as well already in the range of 107 to 110 kW per cylinder with an electrical efficiency of about 42%. And with our next generation of hydrogen engines, we target to achieve the same performance value what you can see and achieve with our natural gas systems right now. To sum up the presentation of Anna, Robert, and myself, the key takes are: first, HVO is the better diesel with the capability to reduce the CO2 emissions up to 90%. Second, exhaust emissions like CO, NOx, and particles can be reduced significantly as well. And number three, our gas engine portfolio is H2 ready, and we have demonstrated the capability to run with pure hydrogen as well at our test beds already. Thank you very much for your attention.